Namaste, Hamisha Khush Raho Betiya. My name is Manisha Singh. Today I am teaching you effects of processing, storage, and interaction of various environmental factors on such potentials of foods and health to benefits. Number one is dietary carbohydrates. That is, dietary guidelines for developed countries are consistent in recommending an increased carbohydrate intake corresponding to at least 55% of total energy. Correspondingly, the carbohydrate content in diets typical for developing countries should be maintained at a high level. The nutritional quality of the carbohydrates and the effects of processing on the food on that quality then becomes on concern because both the content and the nutritional quality of food carbohydrates can be altered by processing in a number of ways. Carbohydrate loss through bleaching, that is, low molecular weight carbohydrates. During wet heat treatment, as in blanching, boiling, or canning of vegetables and fruits, there is a considerable loss of low molecular weight carbohydrates as well as micronutrients into the processing water. For example, in the blanching of carrot and sweeties, there was a loss of 25 to 30% and respectively of these carbohydrates. With subsequent boiling, another 20% was lost. In peas, green beans, and Brussels sprouts, the loss was less pronounced, about 12% following blanching and another 7 to 13% at boiling. The loss of glucose and fructose at boiling was higher than that of sucrose. The losses of low molecular weight carbohydrates in carrots have also been shown to differ between various cultivars and also to be different at harvest and in storage. After storage, the loss of low molecular weight carbohydrates increases following boiling, most probably due to the higher water content and therefore also a higher diffusivity. The loss of low molecular weight carbohydrates, at least in carrots, seems to be relatively easy to predict by knowing initial concentrations and process conditions of the raw material. Next is the dietary fiber. No leaching of the dietary fiber into the processing water has been reported with blanching, boiling, canning of carrots, peas, green beans, and Brussels sprouts. With sweeties, however, there was a 40% of loss of the dietary fiber with boiling. Also, with canning, there was a leakage of insoluble fiber into the processing water. Next is the alterations of low molecular weight carbohydrates. Number one is production of resistant oligosaccharides. The production of resistant oligosaccharides by enzyme technology is an expanding area. More than half of the functional foods on the Japanese market certain prebiotic oligosaccharides as active component with the aim of promoting favorable gut microflora. Fructooligosaccharides synthesized from sucrose and galactooligosaccharides synthesized from lactose are the most extensively used types of resistant oligosaccharides. Alternatively, fructooligosaccharides can be produced by hydrolysis of inulin, then Maillard reaction. Non-enzymatic browning reactions occur between the reducing sugars and amino groups in foods at processing and in storage. These reactions are temperature dependent and most extensive at intermediate water activities. They are important nutritionally as they may diminish the bioavailability of amino acids, especially lysine, thus diminishing the protein nutritional value. The carbohydrate content and availability is influenced only marginally when a non-reducing disaccharide such as sucrose is replaced by, for example, high fructose corn syrup containing glucose and fructose. Maillard reaction occur much more rapidly and extensively. This has to be kept in mind in selecting processing procedures and storage conditions. Next is the starch heat induced effect, that is the gelatinization. Gelatinization refers to the irreversible loss of the crystalline regions in the starch granules that occur upon heating in the presence of water. The temperature range during which the crystalline structure of the starch granule is lost is dependent on the water content and on the type of starch. The gelatinization dramatically increases the availability of starch for digestion by amylolytic enzymes. Usually, the starch granules are not completely dissolved during the food processing, and a food can be regarded as a dispersion in which starch granules and or granular remnants constitute the dispersed phase. The degree of gelatinization achieved by most commonly used food processes, however, is sufficient to permit the starch to be rapidly digested. Consequently, even food processes which results in a low degree of gelatinization, example steaming and flaking of cereals, produces a postprandial glucose, blood glucose and insulin increment similar to that completely gelatinized food. Retrogradation. Gelatinized starch is not in thermodynamic equilibrium. There is therefore a progressive reassociation of the starch molecules upon aging. The recrystallization is referred to as retrogradation and may reduce the digestibility of the starch. The retrogradation of the amylopectin component is a long-term phenomena occurring gradually upon storage of the starchy foods. Amylose, however, reassociates more quickly. The crystallinity of retrograded amylopectin is lost flowing following reheating to approximately 70 degrees Celsius, whereas temperatures above 145 degrees Celsius are required to remove crystallinity of retrograded amylose. This is a temperature where above the range used for processing of starchy foods. This implies that retrograded amylose, once formed, will retain its crystallinity following reheating of the food. Next is the parboiling. During parboiling of rice, the kernels are subjected to a pre-treatment involving heating and drying. This process reduces the stickiness of the rice, possibly by allowing leached amylose to retrograde and or form inclusion complexes with polar lipids on the kernel surface. Parboiling oil also affects the final cooking properties of the rice. Next is the starch texturization. In pasta products, gluten forms a viscoelastic network that surrounds the starch granules, which restricts swelling and leaching during boiling. Pasta extrusion is known to result in products where the starch is slowly digested and absorbed. Available data on the spaghetti also suggests that this product group is comparatively rich source of resistant starch. The slow release features of starch in pasta probably relates to the continuous glutinous space. This is not only restricts swelling but possibly also results in a more gradual release of the starch substrate for enzymatic digestion. Pasta is now generally acknowledged as a low glycemic index food suitable in the diabetic diet. However, it should be noted that canning of pasta importantly increases the enzymic availability of starch and hence glycemic response. Then milling and peeling. During milling of the cereal grains of refined flours, the outer fiber-rich layers are removed, resulting in a lower content of the total dietary fiber. This reduction is due to mainly to a decrease in insoluble fiber. The dietary fiber composition in both whole grain and refined flours is different. Refined flours of oats, barley, rice, and sorghum contains mainly glucans, while and arabinoxylans dominate in refined flours of wheat, rye, and maize. Whole grain flours all contain considerable amounts of cellulose. The husk, which surrounds barley, rice, and oats, also contain considerable amounts of xylens. This fraction is generally removed before consumption, but oat and rice husk are used to fiber preparation to enrich the foods. The summary of this topic is the processing of food affects carbohydrates and micronutrient content and bioavailability in different ways with either desirable or inadverse effects on the nutritional value. Losses of water soluble nutrients at blanching and boiling can be minimized by the use of small amounts of water and by adding back the processing water. The bioavailability of starch is affected dramatically through processing regarding both rate and extent of small intestinal digestibility. This permits optimizing the digestion of starch by choice of raw materials and processing conditions. Processing effects on dietary fiber include solubilization and depolymerization that can influence physiological effects both in the upper and lower gastrointestinal tract. Formation of resistant starch and the use of resistant oligosaccharides as food ingredients provide new opportunities to increase the amount of carbohydrate available for colonic fermentation. Hope you all are satisfied with this session. This session is powered by Digital Version 2.0 Jyoti Vidyapeeth Women's University Jaipur. If you have any query, please mention it in our comment box. I will resolve them whenever we have a live session. Thank you so much for watching.